Okay, I don't know. It's still trying. Okay, great. Uh, it's connected. Okay. Um, so we're going live now. With this first stream. The first stream for today, but we're going to continue our development. So last time we fixed the problem, and now we're back to continuing development like usual. So what I want to do now is really quickly implement so we can change the text, the color of the viewport. Now what I'm gonna do is I'm gonna create a function. Let's call this function overhead window. I'm gonna call it a void viewport color. And what this is going to do is that it's going to allow us to change the viewport color. And if I go inside here and I go, oh, shut the fuck up, Steam. And I go up to where we have our window. And I go void viewport color. And all I'm going to do is paste this in here. Now it's going to have a few arguments. I think these are GL floats. So GL float are, in this case red, float green, float blue, RGB, and then GL float alpha. And they're going to pass through here, so we got red, green, blue, alpha, and that's it. And then we'll copy these arguments into our header file. And then let's just go and call it, so let's call it, let's go, window dot viewport color, and we're just gonna go. See, we want it to be a what color? 0.3. Well, we're just gonna go with what it says here. You know what? That's good enough. That's fine. That is where we are currently. Alright. Now it should change if everything works correctly. There we go. Now, usually the hardest part is actually rendering a triangle. Because there's so much work that goes into rendering a triangle. But the next chapter is rendering a triangle. So there's a lot of stuff that we need to do. I plan on going through it all right now. But essentially we got a float here. And what I want to do, and what we should probably do, is go install this somewhere here. Once we're done with most of the, we can start working on this. So we'll be at vertices. I'm going to call this the triangle vertices. And now it's within like the NDC. There's not really an easy way. I mean, we could use matrices to convert it into like world coordinates at some point. But for the time being, that is not necessary to do. But that might be something that we should implement at some point. And then of course we'll need our VBO. Now, when we create the VBL, we want to have a class for it. So first of all, we want to have a base class. So we want to have a class, call it, this one should be of buffer object. And this class should have anything to do with buffer objects. So as a public variable, we want to keep track of the vertices. And keep a actually this should be protected, right? Protected. We want to have a protected, and then we want to keep the vertices here because we don't really need the vertices to be accessed elsewhere. But we want to keep a std list for the time being. I did include lists, didn't I? Yeah, std list, std list, and the type should be float. The reason why we're using lists is that it's quite efficient when it comes to removing and adding stuff. It's quite fast at that compared to vectors, where it's really fast at it when you add to the end of it or remove from the end of it. But if you let's say need to do it from the middle or something like that, it's quite slow at that. It's not super slow, but it's slow enough that it might be more efficient to use lists. So yeah, but this should contain the vertices, and we don't need to set it right now. But this is basically what we're gonna have here. So only the class itself and its derived classes can access it. Then afterwards, we're gonna have public functions such as void bind that should bind them together. This should bind the buffer object. I have some source code on GitHub that I can go and show. Here we go. From the old one that I worked on in Visual Studio Code. Right, there we go. But as you can see, should be somewhat for buffer objects here. So we have a protected, and in this case the vertices should probably be public. Actually, the buffer object does not actually need to store them. Inside of protected, we can store the unsigned int buffer object type. That's it. In public, we can store everything else, like the bind function and so on. Usually, you do it the opposite way, so you got protected stuff first. It's like this. And here we have stuff like unsigned int ID that should store the object ID. And when we bind, all we go and do is that we go and call GL bind the buffer. And what we pass through is the buffer object type and the ID. That's it. For unbind, it's very similar way. Except we go GL bind buffer, and we pass through the buffer object type and we just go super. That will automatically unbind it. So that's quite straightforward. As you can see, I've done most of this code already. So yeah. But that should handle that. As for here, let me actually go in and add one for the viewport color. public void viewport color. And what we can do, and what I've done, is that we can create a struct at the top of the map. Actually, at the top here, called color. It will handle anything related to colors. So if we create, let's say, a struct and we call it color, or something like that, and then we go geo float red, geo float green, geo float blue, and geo float alpha. Then in that case we can keep track of in that case we can just ask for a color struct instead. Color, and actually in this case we need to make sure all of these are public. Actually I'm not too sure if you do. I think in C# you do need to do that, but here I'm not actually sure if you need to. Color dot, yeah, you don't need to. Red, color dot, green, color dot, blue, and color dot alpha. There we go. And this is another way we can do it. This significantly simplifies the amount of arguments that we need. So, yeah. And its parameters, it has significantly less parameters now. And that's it. At the top right now we can go and in this case we should probably do it like below window, below here, and go struct color. And then we can have like hashtag variables, and it can be geo float red. I don't actually know what to type here, but so let's just go to geo float green. And blue. I guess we can just say that for all of them, because in reality they all need to be between 0 and 1. So yeah, and that's it. That's all. And that handles the color struct. As for the buffer object, we can add a class for it right below GUI. So go class buffer object, then go for it's protected. What variables this will be unsigned int buffer object type, and then go. Yeah, it's. I don't know, something like that. After this we got a public unsigned int ID. Debuffer. Represents the buffer. That's the ID that represents the buffer. Then afterwards we of course have a couple of methods with the bind. This just binds the buffer, there's not much else here. That's all it does, so I think we're good now. So again, VOs are not buffer objects. VBOs and EBOs are, so we need to make sure that they are derived from buffer object. So yeah, for VAOs we usually just want to define them below here. So we have a class called VAO. And this should just contain the buffer object. So VAO again is just for the vertex array object, and what you want to have is again a public unsigned int ID. And then afterwards we of course have the public we got the public creator for this, so just VAO. There isn't much else to say here. This will create a new video. That's all it does for me. Over here we have public void bind, and this video, that's all it does. And public void unbind, which just unbinds a video. That's it. That is all it does. For VBOs and EBOs, it's a bit more complicated. but they have a lot less methods because they had from buffer object, which contains the bind methods and other things like that. But they do store their own vertices, so I didn't even know GitHub had this functionality. Oh, so yeah. What the fuck? Bro, no. Give me a second. But as you can see, there's a lot of stuff to do here. So yeah. But the next step would be the VBO. We're gonna wait with the EBO for later. But the class should get class VBO, and it should inherit from public buffer object. And of course, it always starts with a public unsigned in ID, which a VBO. And after this, we want to go. You see how we have a few different functions here. We also now we go on to the public. Actually, we don't have the ID. The ID is not stored here, but instead we have a public. In this case, it would be a list with floats in them. Call it vertices, and that's it. So we got a list here which contains the vertices. Contains the vertices, that's all it is. We might change this to a vector later on if I feel like that's needed. But we also have a public VBL which just contains a list of floating points, and this is just the vertices list. And that's all of this. This creates a VBO, that's all of this. As far as parameters, this just tells it whether to find the vertices. So we have what? We got the list float vertices list. And that's it. Then afterwards we have got a public VBO. that is a little note that is important. After this, we have the void vertex attrib pointer. Now, from the way this works, I believe it just tells you like it gives you information about the vertex array. Here I can give you an example of it if we scroll a bit further down. So this is a vertex array, right? You'll notice how we got the x, y, and z, and the stride in this case is just whatever the size of what we're dealing with. So in this case, we have 3 values here, so we go 3 times the size of float, which would give us the bytes of all of these 3 ones right here. It makes it very simple and easy to do, and once you understand that, it's actually quite easy to understand how this function works, or how this works. So yeah. So each of these vertexes is represented by, so each of these is a separate vertex. So yeah, and the offset just says, hey, if we store extra information beyond the 3 ones here, we want to specify how far beyond here we want to go. So if let's say that we're storing color values of it too, of the object, we want to make sure that we specify, hey, after 12 bytes is where we start having the colors, so it knows. And this just specifies the beginning index, so what byte to start at, and how many items there. In this case there's 3, but if let's say you had RGB A, it would be 7 if I'm not wrong. So yeah, it's not that difficult to understand. This just tells it what data type we're dealing with, and this I believe is for normalizing them, which just normalizes them between I think 0 to 1, but generally it's not necessary at the moment. That's my understanding, and I think it's pretty accurate. So yeah, but again, we need a vertex array pointer. I haven't changed this one too much because I didn't want to end up messing around with it too much, so I just generally leave it at whatever it's by default. Right, let me go to the documentation because I don't want to fucking write this. Let's see. I used to keep public separate. I don't want to do that anymore. But let's try to find the VAO. Here, I found it. Then let's see VBO in this case, which contains this. And I'm just gonna copy this video because I don't want to write it myself. This is what I've already written. And that's one of those. And then here we have the parameters. And that's all. Oh wait, we got one. And that's all we want to do here. I don't want to have to manually. No, please just go away. Alright, after this we have a void enable attrib pointer, I think. Attrib, and that's all. We're gonna paste here. I said this, paste this. I don't want to spend too much time writing this video. This that's all it does. So the parameters is let index, and this just tells it the vertex to enable. That's it. So yeah, I think that's it. We also got the class. No, we also have the override buffer. Void this just overrides the buffer. That's all it is. It's quite straightforward. But yeah, that's it. That is the VBO and VAO. Those two that we need for the time being. So yeah. As for implementing them into here, viewport color analytics and color arguments instead. So gotta make sure we specify that here. It's now color instead. I actually should define the color struct at the top. You can do that, right? You can declare structs, can't you? I think you should be able to, right? Yeah, you can do that, and then you can define them over here with no problems. As for the main, now we need to change this to a color. I think it's possible to create a new color like this, right? So I don't actually remember how I did it originally. Give me a second to get back in on the actual script itself, because I know I had something about this here. Nope, you have to do it like that, but that's fine. Wait, it used this, but alright, yeah. There must be a way to do that. Okay, you have to make a cast, I guess. But in this case, why can't you just do this? Like, if it goes to a point. Does this not work? Damn, that really sucks, you know? Too many initializer variables. Can you just not set like color equal to dynamic or something like that? No. Color is not undefined, it's part of this fucking variable. See? I guess we have to use a separate color then. So we go color is equal to, and then on array of this. This does not work. What? Why does this not work? Damn. That fucking sucks. What the fuck came out with this? God damn it. I know there is a way to do this. It's just I forgot it. In C sharp there's a way. Maybe this is that? No, that probably doesn't work. It's not initialized. Fuck. Do I really have to go like that? Color dot local variable is not initialized. Technically, we should not keep this within a while loop. We should keep it outside of the while loop and set it inside here. As that would be faster. Problem is that we went into a small problem now, and that is the fact that local variable is not initialized. What do you mean? How the fuck? Lies. See, I wish this worked, but sadly that does not work. Not in C++ anymore. As for a default constructor, I'm using pretty new versions though, so this is from 2019. What version, what standard am I using? I might want to go up to a newer one. It would be instead of the project properties. Let's see, C/C++. I don't remember what it says, what standard it is. Preprocessor, no. There's a place where it mentions that language here. Choosing the 2014 version, I want to use the 2017 preferably. It's a bit newer and offers some more features. It's equal to 0.0, This in theory should work, but no such luck. Really? That's all you have to do? No, because that does not work. Add another one? What? Add a comma? This is confusing me. But this still does not work. So yeah, that's kind of the problem. This is not valid code. We could make a struct. I'm learning so many new things. Okay. Okay, so we should probably define a default structure for them then. But yeah, if you go look at this code, this is completely valid, and it's using the 2019 version. But this might be a bit older, but we can have a default constructor here for this, and all we really care about is spread. G. Okay, and then we can just set red is equal to R, green is equal to G, blue is equal to B, and alpha is equal to A. There we go. Get it over with now. And then we can continue. So half of these variables are lighting up and the other half is not. This should fix my problem though. So let's just go up to the top where we have the color. So in this case we have a constructor. This would be color. Maybe we should put it underneath the variables. Like, I don't know, like this. GL float B, GL float G, G, GL float A. And then go, and then afterwards we can just go color. Then we're gonna have the param pointed here, so go for R. Just gonna duplicate this because there isn't really anything else that's changed. G. And that's it. So now it should have a default constructor, meaning in main we don't actually need this anymore. We can just straight up go color, and color taken. Isn't that how constructors would work, right? Why is this not valid? Is it because it has to be a or something? No? How does structures work? Yeah, here we go. You see it right there. Here we go. Really? Okay, this is so confusing. Who the fuck designed this? So you can have multiple constructors? I mean, that's not so new to me. But why? So in theory, we should just be able to create like a new color. And promise it's still fucking arguing with me. Who the fuck came up with this shit? What brings it up to the side? Close. So we got some data types. We got struct name. Yes, we got some data type 1. So we create a what? You know what we could also just do? Instead of doing that, could just go and upgrade it to the 2020 version. I wouldn't be against doing that. It's a bit new, but yeah, it would make sense. Just do, and it would work just fine. Plus, it will allow for some newer features to be used, like it would allow us to do this. But I'm not actually sure how the Microsoft compiler works, but still color. I wonder why this can't just be done. Or it should be also equal to new color, right? Is it because I put this in the yellow? Is that why? Because it's constantly finding this error. No, now it can't find it anymore. Alright, we should define it in the my bad. It's because we did not define it in the header, that's why. We should define it here. That should allow for functionality like this, right? Technically, we don't even need to use the 2020 version anymore. Not that it matters, it's pretty new, but this would be valid code now. We don't want to create a new color every time if we're just planning on using the same one. This is valid, right? Apparently not. Can we set it like equal to this? Two main initializer variables. But technically this is valid, so that's much better than before. Although now everything seems to be glitched out. That's interesting. We could still include the structure though, but that would be pretty much unnecessary. So here we only really need it to be defined in the header. Yeah, there we go. We can set equal to my default one now. Yeah, there we go. It's working now. In fact, I don't even think I need the equal sign anymore. This is valid code. So yeah, we can just pass through color. This will make sure that we don't create a new color structure every time the window lip finish. Every single time this called in the window lip, which is faster to do it like that. So yeah. In this case, I got some default colors, so yeah, that we can use over here. What was that? Okay, I got them here, so it's not a problem. Here we go. And if we run this now, it should just set the viewport color. There we go. Everything works. So let's now go ahead and create the classes that we need. So we've already created the buff object class, but we have not created the VAO or VBO classes. So VAO should just have a public which should contain unsigned int ID, a void bind, which should gel vertex array. Is it just called bind? Gel bind vertex array, that's what it's called. And this should bind the ID. Void unbind should just gel bind vertex array and should just go through. Easy. And that's all it should do. Yeah, here you go. You see, what's it? It's not here where we do that. It's not hinge. But if I scroll down to the URL, that's what we do here. Okay, great. And then of course also the BBL. Actually, we should not define functions here. But I'll just copy them over, so it's fine. Here we of course want a public unsigned int ID. The ID is still stored here, but it should be a public member of object. Public unsigned int ID. Why is this ringing now? I see, there we go. And afterwards we of course want the stuff that we need. So in this case, the vertex attribute pointer. I want it to be created. Not this one here. Finally, this one as well. And now go back here. Void object bind should be set to whatever the bind function by default is set to. Let's go check this. Then I'll just go void I think we can just do the same thing with serve, so yeah. And then we can just go like this now. And that's it. Same down here with the VAL once we create it. So then afterwards we'll go bind, and it is the same thing really. We just go and copy this. And then we bind these two functions. Go like this, void VL unbind, and then just go serve. And that's it, really. Now for the VBL, it's a bit more complicated because we got different things. In this case, we're mainly interested in the which should be defined here, of course. Why the fuck does that not work? It's missing parameters, that's why. This is the enable one. Void. This one should have it. And it should just call one function. This. And this one is just missing the GL unit index. That's it. Now it's valid. And it also only needs one line of code as well. Then after that, we void VBL override buffer. Same thing here. In reality, all I do is to handle this. And in this case, we don't actually have the vertices. With the ID and everything. However, in this case, we don't actually use. Wait, does it store the vertices? No. But it should, so we should have a public place for the vertices. But yeah. They should be part of here as well. And in this case, they should be a list instead. I've never used lists for this, so yeah. But anyways, on that note, I should probably do I mean, I could just figure out how to get the in reality, it's just more about getting the value, the maximum size in bytes in this case, because if we go back here and we go look at this one. in reality, what we need to do is get the maximum the capacity of it. So vertex vector capacity. Figure out what the equivalent to this is. So in this case, figure out how to store. Figure out how many the current list. Oh shit. Isn't there like a C++ for this? C++. Is it size? I think it might be size. Oh, it's its max size. But there isn't a whole lot of stuff. Right, so in reality, size might be what we're searching for, because it returns the amount inside of it. As for data, vector.data, that is, oh shit. Okay, stream is still going strong, but something killer is wrong here. Oh, it's trying to access a website. Vector.data. C++. My bad. Pointed to the this element storage. Data. We could also just use vectors, you know. Vectors in cases like this probably might be a better choice. Wouldn't take too much time to change this to vector. And then scroll down here, change this to a vector and call it there. That's how simple it is. Now everything here in this case is without capacity. But still, there we go. So that's it for now. As for anything else, Wally, we want to use as for the EBO, we could do EBO too, but really quickly we should have the default constructor and constructor here as well. In reality, I determined that the ID will be created by the buffer object, so no reason to keep that here. But what we do need is these two. The default one, we can just keep this here, but this one we should fairly go with it. In this case, we can just go and instead of doing this, we can just go with this to the buffer object type and set it equal to this. But all we really need to do is just go copy this video. and just let this one handle that. So the VBO. Should be just this video, and then of course we want to have a and then after that we just want to go this and call it a day. That is how simple this is. We of course have a default constructor, because there's some cases where a default constructor is nice to have, like if you're passing it through an array or something like that. As for over here, we'll have to scroll down and make a couple of changes to this. Instead of using lists, we're just going to use vectors. And that's it. So yeah, that's all I really need to change for now. But yeah, as you can see, things seems to be going pretty well right now. So let's try to render a triangle now. So the first thing that we want to do is also we need shader programs and so on. But yeah, after this we need to create a VBO. In reality though, we probably want to create a VBO first, but let's just create the VBO right now. So we need a VBO, VBO, which is equal to VBO, which takes in the, in this case this has to be a vector float, and that's it. Call it vectors and pass through vectors here and call it a. That's all I need to do to create a VBO. And then afterwards, all of this should be handled by the C++ file by default, so we don't need to do that. I mean, we can jump straight into writing shaders now. For shaders, it's a bit more complicated right now because we'll need some classes too for this. We'll need some classes for shaders. Luckily, I've already written those classes for us, so yeah. While working on this engine, I did a bunch of refactoring. I constantly refactored the header file to allow it to do the stuff that I needed to do, but encapsulating the code much more and more and more, and also reducing the amount of duplicate code. So yeah. Anyways, above pretty much everything, we want to have the shader class itself. Delete shader should just delete the shader. This just sets it equal to 0, meaning there's no longer a shader there, so yeah. But for here it just means that when we get to delete shader. But here shader, delete shader, we just want to go do this right there. That's all I want to do. And I think this is the void, so yeah, then afterwards we can just go and with that. That is how simple it is. That is all the shader class has. And now we just have the vertex shader, fragment shader to deal with. Those luckily are not so difficult to make. So yeah. Further, yeah. Let's write that into the source really quickly, or into the documentation. After the GUI, we have a class shader, and this shader, we should have some description. And this one, this shapeless. Gel. So yeah. Inside here, we merely have a public shader. This shader. That's all it does. And then we have a public void delete shader. And that's really all that's for this class, to be honest with you. So we should start putting more space between our classes, so like have there be some space between them so it's easier to navigate around in the file. Because at the moment that's kind of difficult to do. And I'm finding it to be slightly annoying already. Let's see, like that. And that's the namespace, so we've reached the end now. But further down here, it would be very nice if we could start doing that, so it's easy to tell when you've gotten to a new class. Now it's much easier to navigate. Okay. There we go. And that's it, really. So yeah, for actual shaders though, we need to go look for these. So yeah, they don't actually store these shader source, they just store that variable. But they do have they mainly just have a constructor for creating them. But that's all they really need to have. So yeah. I'm not looking to do this, but I'm looking to do down here. Class vertex shader. And if I go to the here we go. Then underneath here we can have a vertex shader class. Like this. Copy all of this. Go inside here. Go underneath here. Go. Void. Actually, just go. Vertex shader. Create it like this. Go. Construct. Color there. Then just go like this right down, and you're good. For the documentation, we really only have one thing necessary, and that is the constructor. So that's all it does. Shader. What argument did I have? This. I don't know what I wrote for the documentation. Let's assign and it compiles a vertex shader. That's what it does. And as for its parameters, you got const char vertex shader SL, which is what it's called, right? GLSL source code body protection. That's all you need to. And that's that class. The second class is just the fragment shader, but it's basically the same thing. So. But instead of this, you have the fragment shader source, but it's basically the same thing. So yeah. Signs and compile say. And that's it. That is all you need to really write down the extra information about this. So there you go, you're done now. That's it. And we can copy this over here as well. Over into here. Go vertex shader. In reality, that's about it. Go here, frag shader, go like this, go go right down, copy, and that's it. That's literally all of this. Yeah. Again, very simple. And now we have the shaders done. I'm just gonna open up the source code here, so we can copy the shaders. Because I don't want to have to write them myself. Here we go. Now we got the shader sources. We can go up again to where we write the thing. For the vertex shader, it's quite straightforward. We just create a new vertex shader after creating the VBO. Go. And we go vertex shader is equal to and we pass through the vertex shader source. And that's it. That's all we need to do. It'll handle the rest for us. And same with the fragments. So you already wrote a majority of this code a while ago, back when we worked on the old bytes engine. So fragment shader. We'll attach the fragment shader source and call it a day. And that's it. Then we'll handle the fragment shaders. Then there's the shader program. Now I'm really quickly going to run it to make sure there's no actual build errors, and we'll look to be in the clear. Great. So next up we have the shader program. Now the shader program does contain a lot of stuff, so Yeah, there's a lot of stuff to go over here, but really quickly first, I would want to write the to this file about the different functions that we've added to it. This will shader. This does the same thing, but so yeah, and this down here will bind our object, and this isn't there a function like further down for? Yeah, there is. I think we forgot to include the one that handles creating VARs. Did we? Yeah, wait, there's actually one for doing so. We should probably include it. Copy these two. Go inside here, go. And before we do any of this stuff, we want to go. VO. This. Then all we're going to do is go. There we go. We got that handled too. So that's it for now, really. I should add that to the documentation as well. VL. Oh wait, it already has that here, so that's not a problem. Okay, good. Let's just create some. Cubic. Here we go. Pointer. And this. VVO buffer. And that's it. We went through a lot of stuff right now. How long have we been live now? For about 1.5 hours. Alright, so let's see. I want to finish rendering a triangle. So yeah, and the next step is to create the shader program. But we could do the EBO first. Which I think we should do because we'll need this later. So EBO next. First of all, there's all of this stuff right here. Copy this to the override into the one that overrides them, and go EBO, EBO, EBO. this just needs to be the buff object. That's now equal to this. And obviously it has to have a there we go. And then of course it also has the override one, and it has this is copy the entire class, so it shouldn't be a problem. It also has this video. Give you override buffer. That's it. Yeah, okay, we need to specify what it's just void. And we're done. What we never want to do is go around to the class EBO say of buffer object public float indices, and that just contains the. That's all it does. After this, we obviously want to go with the public EBO, which in this case should just be it. Actually, this should be a unsigned int, and this should be it of time unsigned int as well. And then for the parameters, it's same thing. It doesn't look like it's just vector anywhere else. It's good, but alls we have what exactly? Got the override buffer, so void override buffer, and that's it. That is all it does, so yeah. That should be it though. I don't think it has more than that. No, it doesn't have anything else, so we're done. That's the EBO done. Now we really only have the shader stuff left to do now. So after this we have a shader program and we're done. That's the last thing, and then we can start drawing stuff to the screen. Shader program is quite large, so, but it's actually not that hard. Most of it's just that. So inside here we will go up here past this. Here we go. The shader program. Shader program. And we will go. This, I don't know, it does take a couple of parameters. Let's copy these. Get them into here. I think we should probably write documentation for them first. Let's go over here. Do not separate them. No space. There we go. Neither. Oh wait, here it's actually not a class. Let's go up to where we create the vertex shader, fragment shader. This we create the class shader program. And this one contains a shader program. That's all it is. These should also be public. Yeah, should be public. So public. Public shader program contains these arguments. I don't actually remember. Creates a shader program. Until this. Don't actually remember what the documentation said about this though, so go back. We won't really need this anymore, so yeah, I've pretty much copied everything that I wrote last time, but I think it's something about this shader programs here. Shader programs used to create, attaches, and compiles a shader program there. That's what I was searching for. Hey, there we go. Okay. That is that. Yeah, okay, great. For this parameters you have which is just the and the fragment shader, which is the and that's it. Avoid use shader program. That one just uses I think this one is very straightforward, so that's what we should talk about here. Alright, this one. I'm just gonna copy whatever it says because this is something that we're gonna deal with once we get around to dealing with shaders. And this thing actually just returns something. Usually these don't return stuff. So I'm just gonna copy whatever I did last time. Let me just go up and go back here and one of these here. And I think that's it, really. Yeah, that's it. Okay. Now we can start to just copy all of this from here. GL use shader program. Oh wait, it's now dot red dot green dot blue dot alpha. Oh, copy this. This should just be a void, and this should be it. But this one essentially contains for the parameters, it's just this way. And anyways, this should mark the end of needing to copy and paste stuff. So yeah, it's the viewport color. This is a little more complicated, so here's a longer note on how it works. And this, I think I had a comment. I'm just gonna copy whatever it says here. I'll look into this at some other point. Oh, that's the next thing that we'll look into after we've rendered a triangle. But yeah, that's it for now. We can set up everything right now, and then we can render the actual triangle tomorrow. But now we need the shader program. Shader program is equal to shader program, and we'll just pass the vertex shader and the fragment shader and call it a day. That handles the shader program, and at this point I think we're mostly done with. I don't think we'll need the byte engines get out to be open anymore. So like at this point we have the shader program as well. And now we have this stuff here, which it's quite straightforward actually. You just go attributes, and what we'll do is that we'll call VBO dot vertex attribute pointer, and I'll just paste this stuff in here because it's what we need right now. And then afterwards VBO dot enable vertex range. And that's it. Okay, we also need to make sure that we tell it to use the program once we're done. But I think we can do that over here from now on once we get to triangle. We need to use our shader for that use shader program. Technically, we can just make it .use. There's no reason to include the whole shader program part of it. .use. There we go. It's a little easier, and I think it's pretty in this. I think everybody knows what this means. It means that it's using the shader program. And that's all we're really going to do. So for the vertex array object, this has to be defined above all VBO. So let's say here we will go VAO is equal to VAO. So this will handle that. And they'll all be bound by default, I think, if I'm not wrong. I think by default it binds. Yeah, it does bind them by default, so there's no reason to really do this when they are created. Yeah, it binds them, so that's fine. Now, we can bind this. I don't think it's necessary for us to actually rebind it, but we'll just do that for the time being. And then obviously we can draw it now, so let's just go VAO.bind. Then let's find a GL draw arrays, and let's pass through this data right here. And if everything works, we should have a triangle there. I'm waiting for it not to work. Oh, well, it drew a triangle. Problem is it's slightly off. So in this case, we did use size of flits. Oh wait, that's right. Actually, in this case, we want to bring up bytes engine again. I know what went wrong with you. It's because when you're dealing with this, you want to use bytes header docs. You want to, I mean, let's see if you're ready. When you pass through this, nope, that's actually fine on its own. Okay, that's fine. I thought it was that, but it's not. In this case, that's a good question to what could be causing that problem, but yeah. Well, the best way of figuring out is to just go look through the code. If we changed anything there, that could cause problems. So let's go look at the source code. Here we go. So first we create a vertex shader here. Make sure that we create a vertex shader. Oh yeah, we should probably create our shaders first before we do anything else. So first we create a vertex shader, then a fragment shader, then our shader program, and we do it like that. Then afterwards we create our VAL and VBL, and this stuff is handled by the C++ file which uses vertices here, so that this is not going to be too much of a concern for us. Afterwards, once we're done with that stuff, we go deal with the attribute pointers. Technically, we can unbind stuff, but that might not be necessary. At least not yet. So actually, when we do this, we want to yeah, we first set the viewport color, then we draw, and then we swap. So yeah, it's likely that somewhere in our code we had something go wrong. It is not certain where, but it's probably something to do with our shaders. In this case, it doesn't look like anything is off, but you know, you can never be too sure. In this case, I'll just leave it alone, and I'll focus on these three ones, because it's likely that one of these three is the cause. I don't think all VAO or VBO would be incorrect. Also, this thing could be incorrect, but I find that to be very unlikely in this case. It would likely throw an error or something if it was really off, and it looks like it's correct, at least from what I can tell, so it doesn't look like it would be wrong. Meaning in that case it's probably something up here, but this just compiles it and stuff, so it's kind of strange why it's not working. Like, the rendering stuff and so on is completely oh wait, yeah, okay, that's because it's 0.6, because we got 6, but we only got 3 right now. That is the max, that's the maximum amount of vertex. That's the length of the vertex away. Well, there could be many different reasons for it. I can go look at domain.cpp to figure out what I did wrong. Oh, why are we binding it again? That is actually a good question. Oh wait, this is the second one, but still, we should need to bind. Yeah, again, unnecessary. We don't need to do that. And we don't have multiple VAOs, so this is unnecessary. So I can, once we've created the VA, so if we go from here, we go std, we got the different ones. Here we got the text array object. Which is the VO, but let's take a look at the sheets first. So, oh yeah, afterwards we should make sure that we delete the sheets once we're done linking them. Not that it matters much, but still. Now we can just go up at text shader.delete shader, and we can go fragment shader.delete shader. It's safe to do it once we've linked them with the shader program. You can delete them with no problem. And then afterwards, let's go up here. So actually we do this above here. In my case, I don't think it matters much when you do this, just that you do it. But as you can see, we should probably actually check if they throw an error. That should always be done, just to be sure. It's called cubic tonnage of W. Here we'll do the same thing again with the fragment shader. Then go cubic, and then afterwards go do it one last time here with the shader program. And that's it. So this should check for any errors that might happen. But again, we'll just go through the standard process. But again, all of this looks correct. Meaning at this point we're probably dealing with some other problem. So down here we create our VAO, then our VBO, with our vertices, then I'll do the appropriate stuff. In this case it's times 7 because we got 7 here. But we're only dealing with 3, so we're just gonna go 3 times. We don't have an offset. And after that, there's an EPO, which we can ignore. And then this for the extra one. There's some draw stuff that we can ignore too. And down here, it just tells us to use that. And we draw stuff down here. So we do the color thing here. But we draw stuff down here. And that's it. I don't think it's gonna make any difference though. No, it's still drawing weirdly. So I assume that there's a couple of reasons why the there's many reasons why there's also the chance that the vertices is wrong, which is actually the most likely case. Let's go look through here. If the vertices are off, then that could be the reason. But in this case, I copied them from here, so that shouldn't under normal circumstances happen. And as you can see, they were not off. So it looks a little weird, but so yeah, in this case I don't actually know what's wrong, but it certainly rendered the triangle, so I think I'll leave it here for today. The stream has been going on for about 2 hours now. I've been live for a long fucking time today, man. But yeah, it could be many different things. I truly only think the only way to know that is to start replacing code. So you can't undo code without stop drawing the triangle, but you can replace some of this code with other code. In fact, just to be safe, we can go over everything here to figure out what could be wrong. So let's start from the top. We're at the top. Okay. VBO. We set the object to the array buffer, which is the VBO. What is the array buffer? Right, yeah, the array buffer. Set the vertices. We have the data, which is the one that we use here. I think this one is correct, but I actually should probably check that. Because if it's off, it'll render the triangles incorrectly. OpenGL. So we could try dot size instead of dot capacity to see if it will make a difference. I don't think it will, but I might as well try something out. Okay, that didn't change anything at all. But that size could work as well. I don't think it matters what you use well in this case. Uh, but yeah, there's something like this right here. This is not the one that I was looking for. But yeah, but we're just gonna keep to whatever the thing says. Anyways, we can start looking through code here to figure it out. Bytes to H. Shouldn't have anything to do with that. Okay, I highlighted out the shaders causing issues. I would expect it to be the same shader that is used here. No, this is a different shader. Bytes to H. Color is a struct, but alright. I would assume it would have something to do with the video. Or the in this case probably the VBL, to be honest with you. Yeah, here we go. You can see it is what I used, and when I tested this it worked just fine, so yeah. Although maybe it's because I'm using a different compiler, but I don't think that would be the problem. So for the time being, I think I'll leave it off here. It's not working, and I can't quite narrow the issue down without replacing a bunch of the code with whatever it says to replace it with here. In this case, currently we can write some notes. It is probably the cause of the VBL or the vertex data being inaccurate, or the vertex attribute pointer being incorrectly configured, but that would probably not be the case in this instance. So in some ways I think it's probably the buffer data that's the problem, but obviously I don't know, because I've had times where it's been a problem and it's fucked up stuff. It's strange, but yeah, there's a lot of different things that could cause it. Meaning it's just about replacing code until you figure out what went wrong, and then yeah, that's what you do. But I don't think these shaders or shader program is the cause. I do believe that it's probably something to do. I mean, that would be relatively unlikely. They only used to compile and store this shader until you link it up with these shader programs. They're probably not related to this issue. It's either the VAO or VBO that's causing the problem. So yeah. There we go. EVO, we're not using any EVOs, so this is not a problem. for VBOs. I mean, there's all kinds of issues. It's either the VBO, we're drawing the thing incorrectly, or we are doing something else with it. In fact, let me go check the source code really quickly. Scroll down to the bottom. Here we go, draw. So draw just contains some information about stuff. For the end draw arrays, we're mainly interested in drawing arrays, that's all. So yeah. In this case, it seems to be pretty much the same. It just automatically puts in a draw mode, and for draw elements, it's the same thing. So yeah. But it doesn't seem as if it's that drawway is incorrect. So yeah, of course we could always just rebind these objects if we wanted to before we go and use them. Just to be sure, we can always just rebind them before we draw it. So go VBO.bind. But I don't think that's going to make any difference really when we only have one of each. And yeah, it's still a problem. Whatever is causing this, I don't actually know. But compiler version should not matter. But yeah, we can do it. But I don't know if there's a specific compiler version that you would want to use. Yeah. But yeah, it's really difficult to tell exactly what I did wrong, but there's probably something. Even a small mistake could cause issues, and it may take a good couple of hours to figure out, so I'll set this aside for tomorrow and I'll look into this while I'm not streaming. But I've been live for about 2 hours now and it's about time to go to bed, so yeah. I'll take a look at this tomorrow. If I figure it out, I might come back and stream for another hour or two, just continuing the development. But it could take a while before I'll figure it out, and I might not have that much time tomorrow to look into it. So yeah, we'll see about that. But hope you guys enjoyed this stream. We'll see you guys next time when we'll be doing the 4th development episode of this engine.